Okay, two more pages here. So in this probability example, we've got liquid medicine is supposed to have a concentration of 0.24 for the active ingredient. So in other words, the active ingredient is supposed to make up 24% of the liquid. However, there's variation in the production process, and the medicine is acceptable as long as the concentration is anywhere between 0.22 and 0.25. So what I've asked here is if y is beta 619, again the first number is alpha, the second number is beta, what is the probability that the medicine is acceptable? For something like this, you would be allowed to use your calculator or again a computer algebra system like Mathematica or Wolfram Alpha. If you have a situation where one of either alpha or beta is 1 and the other, so you're down to one term, you either have y to the alpha minus 1 or 1 minus y to the beta minus 1. I would expect you to do that integration, but for something like this, you can do this numerically. So if we plug in the values of alpha and beta, right there you've got gamma of 25 divided by gamma of 6, gamma of 19, and I wrote out the calculation there in terms of the factorials. If you go through the integration now with whatever you're using to do it, you'll notice that you get a little bit less than 0.14 in terms of the probability. Now, part of what we're doing here is I'm saying, well, let's change the values of alpha and beta, but there will be a relationship here. In the second case, the alpha and beta are 12 and 38, and in the third case, they're 48 and 152. So in those situations, if you were to do the same integral but change the appropriate constants and exponents, you can see that the probability changes from 0.139 to effectively 0.197 to 0.38 and change. And if you haven't already noticed here, what I did in the going from the first case to the second case is I doubled the values of alpha and beta, and going from the first case to the last case, I multiplied the values of alpha and beta by 8, but relative to one another, they're in the same ratio. So what's going on? Well, if you go through the calculations for the expected value of y for each of these three situations, you find out that the mean is equal to 0.24. That was set up intentionally that way. That was the desired level that we want, but we're certainly not always going to get that. You've got the calculation for the variance of y written out there, and then I've gone through and done the same thing in the cases of 12 and 38 and 48 and 152. But if you do some factoring out, you'll notice that we can write these expressions in terms of the 6, 19, 25 squared, and 26 that we have in the other problems. And when you do that, what you effectively find out is that when you double the values of alpha and beta, you end up getting a variance that is approximately a half of the variance in the 619 case, and when we multiply by 8, the appropriate coefficient is 26 over 201, so this is approximately 1/8 of the variance in the 619 case. So there is a relationship there. The variance is getting smaller, so the probability of falling within a certain interval that's got an endpoint on both sides of the mean will end up increasing because of that smaller variance. Okay, now, last one here. We've got another beta. The values of alpha and beta are 3 and 7. And we're looking for the expected value, in this case, of the quantity 1 minus y raised to the negative 4. Okay. There's your value of the appropriate gamma functions, gives you 252. And so there is your density function without the 0 elsewhere. And so if we go through the expected value process, we've got our function in there, 1 minus y to the 4th. We'll pull out the 252, And you'll notice now that the 1 minus y to the fourth times 1 minus y to the seventh gives us 1 minus y to the third. So we still have a beta kernel, except now we're 3, 4 instead of our original 3, 7. Okay, so we'll plug in 3 and 4 into the reciprocal of the constant, go ahead and do the calculations, and we end up getting 21 over 5. So that's how you would handle that case. Okay, well that's it. I will see you on Wednesday.